Okay, sixth graders, we are going to take it a step further today in lesson 3, session 3, which starts on page 53. So we had taken these 3D shapes and we had flattened them out to make nets. Now that we can flatten them out to make nets and put them back together, we are going to find the surface area of these shapes. And all that means is we're going to find the area of all of the faces and put it together. Alright, so our try it here is Oliver is using plywood to build a skateboard ramp. 3 sides of the ramp are rectangles. How many square feet of plywood does Oliver need to build the ramp? So all we need to do is we need to find the area of each of the shapes of each of the faces and add them together. So we've got this rectangle on the bottom, and that one is 4 by 6. And then remember, the area of a rectangle is just base times height. So 4 times 6 equals 24. We've also got this rectangle in the back, and that one is 3 by 6. And I know this one's 6 because this one's 6 over here, and they are congruent. So 3 by 6 is 18. Now we're going to do our actual ramp part, the part that the skateboard goes up and down. So this rectangle is 6 by 5, 6 by 5, so that's 30 feet. And then we're going to do our 2 triangular sides. So this side is 3, oops, I want to change my color so I keep my matching colors. 3 by 4, 3 times 4 is 12, but it is a triangle. Remember, a triangle is half of a parallelogram, or half of a rectangle, because a rectangle is a parallelogram, just a special kind. So now I need to divide that by 2. So that's 6 now. And, oh, these are going to be the same. That's going to be the same size, so I can just do that again. Times 2. We're back to 12. So that's the two different triangles. So 12, and add all of these with it. And that'll give us the area of the full figure, which is called the surface area. Okay, so I did that together really quickly here. 24 plus 18. I'm just going to add my 12 down here, so I have them all lined up. And there we go. That's 10, 14, 1, 2, 3, 4, 5, 6, 7, 8. 84. 84. And it's, the units were feet, and we're talking about area. Area is flat, so area squared. So that's how much plywood he would need. He would have to go down to Home Depot and say, I need 84 square feet of plywood, because I'm building a skateboard ramp. Okay, there are 2 methods here to figure this out that they're going to give you. There's a picture it, and there's a model it. The picture it is basically flatten it, make a net, and find the area of each shape individually, which we did. We found this was 24, right? Am I right, or is that 30? That one was the 30. 24, 18. This one was 30, 24, 18, 6, and 6. We found the area of each piece, add them together, and it was 84 square feet. So you could do it that way, or you could do it basically Actually, we kind of did a combo because I color coded my colors up there. That kind of is like making a net, but what we really did was we did each part separately instead of making a full equation. So they have a full equation here where they have the two triangle sides, 1/2 times 4 times 3, 1/2 times 4 times 3. So those are the triangles, because remember, it's base times height divided by 2, which is the same thing as multiplying as 1/2. Dividing by 2 and multiplying by 1/2 are the same thing. Then we have the 3 by 6 triangle. What color was that one? Then very important we keep our colors the same. That was pink. So this is the area of the pink triangle. And then what color was the other ones? Green and orange. So this one is the area for the orange one, and this is the area for the green one. So they took the area of each part, each individual piece of the ramp, and then added them all together. They just wrote it as one big line, but that's what we did above. Okay, so you have your two methods. Flatten it out and find each piece, or just write it out as a math problem. Either way. Okay, number 1 down here on page 55, we're going to look back, we're going to look up at the picture, which was the flatten it into a net. 2 line segments in the net are labeled as 5 feet long. Where do you see the line segments in the prism? Okay, so they labeled, okay, I see where they've got that label. So they've got 5 feet here, and 5 feet here, and 5 feet here. So, oh, nope, I'm looking at the arrow wrong. This arrow is trying to point at this. So it's the hypotenuse of the triangle. Remember, hypotenuse of a triangle just means the side that's the longest one. So these two pieces will connect. Let's see. 2 line segments in the prism are labeled 5 feet long. Where do you see the line segments in the prism? On the, let's see, how do we, what do we want to word that? Let's think about it. Is it the part of the part that the skateboard goes on? I think that's a good way to word it. Let's think about it. On the front of the ramp where the skateboard goes. Actually goes. There we go. That's a good way to put that. It's also the hypotenuse of the triangle, but it's also the edge of the rectangle. The length of one line segment in the net is labeled as 6 feet. Which other line segments in the net could be labeled as 6 feet, and how do you know? Okay, which other line segments are 6 feet? Let's see. Okay, let's get out the purple because that's what the 6 label. So if this one's labeled as 6 feet, well, what are the corresponding sides? Are the congruent sides? It's probably more accurate. All of these are 6 feet, right? Because they are all parallel and they all have the same length, because they look like it, basically. I mean, I think that's obvious. Okay, so how do we want to word that now? Let's think, because that's the hardest part. We can see it, but how do we write that down? That's the part I know you always have the hard time with, because you know this. It's how do we put it down on paper in words. The opposite sides of a rectangle are equal in length, right? Otherwise, they wouldn't be a rectangle. So, all of these segments, all the segments parallel to that 6-foot segment are also 6 feet. There you go. That'll work. I think that's a better answer than the teacher edition, to be honest with you. Okay, number 3 here. Aisha wrote the expression 2 Let me highlight as I read it so you can see what I'm doing. 2 times 1/2 times 4 times 3 plus 6 times 3 plus 4 plus 5 for the area of the net. Explain why the expression represents the area of the net. So remember, we have to do what's inside the parentheses first. So let's work this out and see if it helps us figure out which part is which. Okay, so we have to do what's inside parentheses first. So this is inside parentheses, so that's 12. This is inside parentheses, so 3 plus 4 plus 5. 3 plus 4 is 7, plus 5 is 12. So now we can simplify that to 2 times 1/2 times 12 plus 12. Okay, remember in our order of operations, we did the parentheses first. There are no exponents. We need to do the multiplication and division before we do the addition. So 2 times 1/2 is 1. I won't put that. 1 times 12 is 12. So then we got this is all simplifies to 12. I'm just going to bring down that plus 12. 12 plus 12 is 24. Okay, so now explain why the expression represents the area of the net. Well, let's see how it matches up here. We had 6 times 3 plus 4 plus 5. So we have 6 times 3 plus 4 plus 5. So this whole area, instead of doing this area and this area and this area separately, what she did is she did the area of this times this. Because 3 plus 4 plus 5 is 12. So this whole side is 12. And this side is still 6. So that's what this part represents. Is that whole long side times 6. And then we have the two areas of the two triangles. The triangles are 4 by 3, but they're triangles, so you have to multiply them by 1/2, but there's two triangles. Okay, now let's write all that down now that we went and figured it out. We actually have to type it out, or write it out in your case. Let's keep it kind of simple. The first part represents the area of the triangles multiplied by 2 because there are 2 of them. Triangles. The second part represents the area of the 3 rectangles combined. Oh, I run out of room. Guess I'll just have to make it smaller. Hang on. There you go. Now you can read it. Hopefully. Okie dokie. What is number 4 here? What is the area of the plywood Oliver needs for the ramp? Explain how a net can help you find the ramp's surface area. So we already solved how much plywood he needs. He needs 84 square feet. And explain how a net can help you find the ramp surface area. Let's think about that. How did the net help us? How did flattening it to a net make it easier for us? Well, when I see it flattened as a net, it's really easy to see the different shapes, right? So let's put that. When it's a net, it's easier to see all the shapes that you need to find the area for. I think that's pretty good. Now, how can you, this is number 5, how can you use what you know about two-dimensional shapes to find the surface area of three-dimensional shapes? All right, let's think about that. Think about, you think about it before you copy what I put. So go ahead, pause, think of your answer, then look to see what my answer is going to be, see if it matches up. Okay. I'm going to put mine right here. A 3D figure, you can write out three-dimensional if you want. I'm going to shorten it to 3D, is made up of two-dimensional shapes. Two-dimensional faces, I'm even going to say. It's made up of 2D shapes for its faces. You can find the area of the 2D shapes, then add them together to find the surface area of 3D shapes, of 3D shape. Okay. Okay, and then this is for you to do the reflect. So think about all the models and strategies that we discussed today and describe how one of them helped you better understand how to solve Oliver's problem up here. So of all the things that we went through, which one thing helped you the most how to solve Oliver's problem building his ramp? I want you to pause, answer that question, and then we will do our practice problems together. Okay, so you've answered number 6 there. Now we're going to do 7, 8, and 9 together, and then you've got your green pages to do. So what is the surface area of this cereal box? Show your work. Okay, well, I need to find the area of all of the sides and then add them together, right? So I've got this top, and don't forget there's a matching bottom down here. So I need to find the area of this top, and it's going to be 2 inches. And I know it's 2 inches because the corresponding side down here is 2 inches. So that's 2. This is 7. And I know that because the corresponding side down here is 7. So the top and bottom are both 7 by 2, which is 14. But remember, there are 2 of them. So 14 times 2, I'm going to change my color there. 14 times 2 is 28. So the top and bottom are 28 square inches. Now we need to do the 2 sides, which are again 2 by 10, and I know this is 10 because this is 10, and these sides are corresponding to each other. They're congruent. Okay, so both the sides are 2 by 10. 2 by 10, which is 20. But again, there are 2 sides. There's this side and this side over here. So those sides are 40. And then we have the front and back, which are 10 by 7. 7 by 10 is 70. But again, there is a front and a back. I don't want to forget about the back. 70 times 2 is 140. I'm going to add all of those together. And I've got 208. 208 inches squared. There we go. That's the surface area of Best Amazing Crunchos. Alright, let's practice number 8 together. Which expressions can be used to find the surface area of the right rectangular prism? And don't forget, it says select all that apply. So what you're going to want to do when you're doing these kind of questions on your own is see if you can figure out, then don't forget to double check with the answer key to be sure you got them all. So let's go through them one at a time. Okay, we have You know what? I'm going to draw the net out, and that's going to help me do this, because this has 4 sides that are all going to be the same, because this side is the same. This side's a square, so these are all going to be exactly the same. And then I will draw these 2 sides in here. I'll just put them right here. They could go on any of these spots, but I'm going to put them right here. 3 by 3. Okay, so these are 3 by 3. So I've got 3 by 3 and 3 by 3. There's one side here and the other side here. Now this has 14. So this is 14. So that's got that so far, and then we've got plus 3, 14 times 3 plus 3 plus 3 plus 3. Well, 3 plus 3 plus 3 plus 3, which by the way is 12. So yes, this one works, because it's adding all the little sides together and then multiplying it by the 14 here. Alright, next one, we have 14 times 3, which is the area of one of these rectangles, and then we multiply it by 4. Well, look, there are 4 of them. 1, 2, 3, 4. So that works for the surface area of the main part. Now, what about these 2 sides? Let's see. They're 3 by 3, and how many of them are there? There's 2 of them. So 14 by 3, and there's 4 of them. 3 by 3, and there's 2 of them. So this one works. This one, we've got 14 times 3, which is a rectangle. 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 But oops, that's it. It didn't cover anything about these 3 by 3 square ends, so that one's no good. It would need plus 3 times 3 plus 3 times 3. But it doesn't have it, so it's no good. This one is just 14 times 3, which is a rectangle, times 3. So this one only covers 14 times 3 times 3. It's missing this whole area right here. Not good enough. Not going to work. This one down here, E, we've got 14 times 3 times 2. Oops. We got 14 times 3 times 2, so 14 times 3, 14 times 3, that covers that area. We've got another 14 times 3 times 2, so 14 times 3, 14 times 3 times 2, so that works. And then we've got 3 times 3, and then 2 of those. So 1, 2, there's 2 of those, so this one also works. So A, B, and E, but not C or D. C and D do not cover enough. Okay, number 9. All of the faces of the triangular pyramid are identical. What is the surface area of the pyramid? Show your work. So it's got 4 identical triangles. Even the base. That one is identical to this one, is identical to this one, and they're all identical to this one in the back. So we just need to find the area of one of the triangles. That's a little too messy for me. We just need to find the area of one of the triangles and multiply it by how many there are. And if you remember, the area of a triangle formula is base times height divided by 2, or, and these are the same thing, so you only have to memorize 1/2 times base times height, because dividing by 2 and multiplying by 1/2 are the same thing. So I'm going to look at this triangle and I see the base is 4 and the height is 3.5. We're not going to use a side. That's no good. The base and the height have to be perpendicular to each other. And if you don't recall that, perpendicular means they go the opposite direction and form the right angle. See the little right angle symbol right there? This doesn't form a right angle. This is not a right angle down here. So that's no good. So we're going to multiply 4 times 3.5, and then because it's a triangle we have to divide by 2. So I'm going to do 3.5 times 4, because I always like to put the longer number on top. With multiplication division you can do that. 4 times 5 is 20, carry the 2. 4 times 3 is 12, 13, 14. In my problem there's one number behind the decimal, so in my answer there must be one number behind a decimal. So 14 so far, but now we have to do that divided by 2 part. So 14 divided by 2 is 7. So the area of one of the triangles is 7 centimeters squared. But how many triangles did we say there were? There are 1, 2, 3, 4. There are 4 triangles. So we need to multiply this times 4 to get the area of all 4 triangles put together. So 7 times 4 is 28. 7 times 4 is 28. So the solution is 28 centimeters squared. Okay. So just remember, all you're doing here is you are finding the area of each face of the figure and adding all those areas together. You're going to do these green pages on your own, and I will see you guys in class.